Have you ever really thought about the ground you're standing on? I mean, it seems so solid, right? Permanent, like it's always been there. But what if I told you it's actually telling this incredible story? A story of fire, unbelievable pressure, and constant change over millions and millions of years. Well, today, we're going to dive deep into that story.
Okay, let's start with this. A rock. It looks simple, maybe even a little boring, but this is a time capsule. It's a silent witness to Earth's most dramatic moments. For the next few minutes, you and I are going to be geological detectives, and our mission, should we choose to accept it, is to crack its code.
So, where does any good detective start? You got to examine the evidence, right? We need to break this thing down, figure out what its fundamental building blocks are to see what it's really made of.
Now, this whole story plays out on this massive stage called the lithosphere. That's just the fancy name for Earth's rigid outer shell. You can think of it like the planet's skin. It's the ground floor for all the action, from mountains rising up to entire continents slowly drifting apart.
And if you zoom in, way in on any rock, you'll see it's made of smaller pieces. These are minerals. They're basically the chemical ingredients that come together to form every single rock on Earth. You know, just like flour, sugar, and eggs make a cake, different combinations of minerals make totally different rocks.
So how did geologists figure out which mineral ingredients they're looking at? Well, they act kind of like forensic experts, using a specific set of clues. They'll test a mineral's hardness to see if it scratches easily. They'll check its luster, which is just how shiny it is. They'll note the color, and they'll even scrape it on a plate to see the color of its powder. That's called its streak. Every mineral has its own unique combination of these properties, like a chemical fingerprint.
All right, so once we've identified the minerals, we can start putting names to faces. It's time to identify the main suspects in our geological mystery, the three great rock families.
First up, you've got rocks that are literally born from fire. That's the igneous family. Then you've got rocks that are built from tiny little pieces of other, older rocks, all squashed together over thousands of years. Those are sedimentary. And finally, you have rocks that started as something else but were completely transformed by incredible heat and pressure deep inside the Earth. That's the metamorphic family. Each one tells a totally different origin story.
And just within that igneous family, there's this amazing clue hidden in plain sight: the size of the crystals in the rock. Seriously, this one tiny detail tells you everything about how it was born. If molten rock cools down really slowly, deep underground, it's called intrusive, and it has time to grow these big, beautiful crystals. But if it erupts as lava and cools super fast on the surface, it's extrusive, and it only forms tiny crystals, or sometimes none at all. It all comes down to the cooling speed.
So, we've met our three rock families. But here's the twist. They aren't totally separate. They're all part of one giant interconnected plot. Let's pull back the curtain and look at the master plan.
You know, a really great way to think about it is like this. The rock cycle is basically Earth's ultimate recycling program. It's this continuous process where any type of rock can be melted, squeezed, or broken down to become any other type of rock. Nothing ever gets thrown away. It just gets a new identity.
And here's how that whole thing works. You start deep underground, where rocks can melt into magma. That magma eventually cools and hardens into igneous rock. Up on the surface, that rock gets broken down by wind and rain into tiny bits of sediment. Then that sediment gets buried and pressed together, forming sedimentary rock. And if that rock gets buried deep enough, intense heat and pressure will cook it and change it into metamorphic rock. And that metamorphic rock, it can get pushed down even further and melt all over again, starting the whole cycle right back at the beginning. It just never stops.
Now, this constant cycle of rock formation, especially with sedimentary rocks, does something absolutely incredible. It creates a record. It's like a diary of Earth's past, and it's jam-packed with hidden evidence.
And the detectives who are experts at reading this diary, they're called paleontologists. They're the ones who hunt for fossils, those preserved remains or traces of ancient life, to piece together the story of what exactly used to live on this planet millions of years ago.
But here's a question. Why do we almost always find fossils in sedimentary rock? Well, it all comes down to how they're made. Sedimentary rocks form when layers of sand and mud gently cover things up, which is perfect for burying and preserving a plant or animal. Igneous rock, on the other hand, is made from scorching hot molten lava. Anything living that gets in its way would just be, well, incinerated. No chance of leaving a fossil behind. And the clues these paleontologists find are so varied. Sometimes they find a mold, which is just the impression something left in the mud.
Or they might find a cast, which is when that mold got filled in with other minerals. If they're really lucky, they find true-form fossils, like an actual insect perfectly preserved in amber. And sometimes, the clues aren't the creature itself, but signs of its life, like fossilized footprints or burrows. This is the secret to how paleontologists tell time. As new layers of mud and sand settle down, they bury the older layers beneath them. So the rock layers really do act like pages in a history book. The deeper you dig, the further back in time you go. The layers at the bottom are the oldest chapters, and the ones at the top are the most recent.
But hold on, the story isn't that simple. The Earth's surface, our scene of the crime, is constantly being changed and reshaped by these powerful forces that can mess with the evidence.
The first of these forces is weathering, and it's exactly what it sounds like. It's just the process of breaking big rocks down into little tiny pieces, into sediment. This can be caused by anything from rain and ice freezing in cracks to wind blasting away at it for centuries.
Now, once weathering breaks the rock apart, erosion takes over. You can think of erosion as the transportation system. Wind, rivers, and giant glaciers pick up all that loose sediment and carry it off to somewhere new. This is the process that carves out things like the Grand Canyon and is constantly changing the face of our planet.
And here's the thing. We are a part of this story now, too. Our activities can actually speed up these natural processes in a huge way. Air pollution, for example, can lead to acid rain, which literally dissolves rocks and buildings. And when we clear forests, we remove the plant roots that act like a net, holding the soil together, which can lead to massive, destructive erosion. Our fingerprints are now being left all over the geological record.
So, that rock we started with, it's not just some static, boring object. It's a character in this epic, ongoing saga of creation, destruction, and renewal. And that leads to one last thought. The ground beneath your feet isn't finished. It's moving, it's changing, and it's writing history this very second. So what story is it writing right now?